Writing the equations of lines parallel or perpendicular to a given line. As we have learned, determining whether two lines are parallel or perpendicular is a matter of finding the slopes. To write the equation of a line parallel or perpendicular to another line, we follow the same principles as we do for finding the equation of any line. After finding the slope, use the point-slope formula to write the equation of the new line. Given an equation for a line, write the equation of a line parallel or perpendicular to it. Number 1, find the slope of the given line. The easiest way to do this is to write the equation in slope-intercept form. Number 2, you're going to use the slope in the given point with the point-slope form, and then simplify the line to slope-intercept form and compare the equation to the given line. So for example 15, writing the equation of a line parallel to a given line passing through a given point. Write the equation of a line parallel to 5x plus 3y equals 1 and passing through the point 3, 5. So the first thing we need to do is we need to figure out what is the slope of this line. And then we're going to use this point that it's passing through to find the other line that it's parallel to. First, we will write the equation in slope-intercept form to find the slope. So we need to isolate y. So we're going to subtract 5x to both sides and then divide both sides by 3. We get y, which is equal to negative 5/3 x plus 1/3. So we figured out that the slope is negative 5/3 and the y-intercept of this line is 1/3. Now the y-intercept doesn't really matter or enter into our problem, as the only thing we need for two lines to be parallel is to have the same slope. The one exception is that if the y-intercepts are the same, then the two lines are the same line. So the next step is to use this slope and the given point with the point-slope formula. So we know that our slope is negative 5/3, so we're going to substitute m to be negative 5/3. We know that x1 is going to be 3, and we know that y1 is going to be 5. Then we're going to solve for y. So in order to do that, we're going to distribute the negative 5/3 to both terms. So we get negative 5/3 x, negative 5/3 times minus 3 gives you positive 15/3. And 15 over 3 gives you positive 5. And then adding 5 to both sides, we get y, which is equal to negative 5/3 x plus 10. So you can still see that we had the same slope, but now a different y-intercept from the previous equation. So now if we want to graph these just to make sure that they are parallel, let's take a look at our points here. Okay. So we have a slope of negative 5/3 in our first line, and our y-intercept is 0, 1/3. So that means it's crossing the y-intercept we can plot right there. It's right above 0, which is negative 1/3. I'm sorry, positive 1/3. And then we're going to use our slope. Our slope tells us that we can go down 5. So we're going to go down 1, 2, 3, 4, and then 5. I'm going to go over to the right, 1, 2, and then 3. And there's our point. And if I'm going to go in the other direction, it means I'm going to go up 5. So I'm going to go up 1, 2, 3, 4, and then 5. And then to the left, 1, 2, and then 3. And then if we graph our other line, we can see that we have our y-intercept at 0, 10. So there's 10. Okay. Then we're going to use our slope. So we're going to go down 5. 1, 2, 3, 4, 5, and then to the right, 1, 2, 3. And likewise, we're going to go down 1, 2, 3, 4, and then 5, and then over 1, 2, 3 to get our points. And therefore we can see from the graph that they're not going to intersect and those lines are parallel.